and today I'm going to give a workshop on IBC SDK, but more specifically on making IBC-enabled CosmWasm smart contracts. I know it's late in the day, but if you want to follow along, there is a repo. It's at github.com, tmsd keys, so tmsd keys, and then /AwesomWasm. This will also be available after, so if you just want to follow along for now and then check it out after, that's fine as well. I'm going to start with a little bit of context for the workshop. So, what is Polymer? Maybe at first. We also have a link tree which you can check out. So it's just a link tree and then Polymer DAO, which will give you an overview of all of our activity online and with different channels. But basically, what Polymer wants to do is to accelerate IBC adoption and extensibility, and IBC SDK works in that context. So first point, CosmWasm was always developed with IBC in mind. It was really developed as being a natively multi-chain or cross-chain, whatever you prefer to use, smart contract development platform. But up until now, we're still at the very start of seeing interoperable contracts or dApps, and having learned it only myself in the last month, I did notice that there's kind of a lack of documentation and materials, and so this is hopefully a start in the right direction to get you more familiar with IBC and interoperable with CosmWasm smart contracts. And so, like I mentioned, Polymer, we accelerate IBC through something we call virtual IBC. And I've also linked here a workshop I gave in Prague at the Gateway to Cosmos event. There I really went through all of the different steps and going to a traditional IBC setup with 2 Cosmos chains and a relayer in between using IBC. All the way through, connecting Ethereum to Cosmos using Polymer in the middle, right? And so this is actually a diagram here. So basically, today we're going to focus on smart contract development. And the great thing for a smart contract developer is that all of the complexity that goes on behind the scenes is kind of extracted away. So if you look at the diagram on the left, we have Ethereum, which would be our so-called virtual chain. Virtual chain because it doesn't have a native IBC compatibility and implementation. And on the other side, we have chain B, which you can think of as a Cosmos chain, and maybe more specifically a CosmWasm chain, which does have IBC natively integrated. And so from the point of view of a contract developer, we can just simply have a multi-hop channel. So that's the difference between a regular IBC channel. This will be a multi-hop channel with Polymer being the hop in the middle. But you can just think of this as a regular old channel, and if you're an IBC application developer or smart contract developer in this sense, today we're at AwesomWasm, so probably you're going to be focusing on the B side. So for you, it actually just looks as if there's IBC on Ethereum, but behind the scenes it's actually Polymer that does the heavy lifting and runs the IBC implementation. But like I said, if you want to find out a little bit more, please check out the link that is in the repo. But today we're going to be focusing on the CosmWasm side. Because of course, if we have Polymer connecting Ethereum and Cosmos through IBC, that's all great. But if we don't have developers that actually know how to build these applications, both on the Ethereum side and on the Cosmos side, then this is not going to be successful. And that's why we have the IBC SDK, which makes it a whole lot easier once you have your contracts written to basically have an automated environment where all of your chains, all of the different relayers that you're going to need are spun up for you, and you can essentially just deploy the contracts that you need and send packets and see if they arrive in the way that you expect. I also want to mention Starship. There was a workshop earlier today, I believe, on Starship by Anmol from Cosmology. And they have built something relatively similar, and we're actually also collaborating with them to kind of like bridge the gap. But what they are doing is right now limited to the Cosmos ecosystem. So you have, I think, two, maybe multiple, I'm not entirely sure, chains that you can spin up, and they will also have the relayers. So if you are a hackathon participant, for example, you could already be using Starship. IBC SDK will be released open sourced very, very soon. Later, I will expand on that a little bit more. So that's not usable yet. That's also why today we're going to be focusing more so on the IBC contract development. All right, so before we start, just a little bit about what we're actually going to do today. So what we're going to do is create a IBC-enabled smart contract in CosmWasm, and it's going to be a simple app. It's a polling app, and let's just focus on the middle for the initial stages. So what we see here is that essentially we can create polls in a smart contract that lists three options from which users can vote. Each poll will have a poll ID. And the poll will have an admin. The admin can create this poll. People can vote, and then the admin can end the poll. And when the poll is ended, they will be able to send over the information about this poll. So each option is going to have counted how many people voted for it, and we're going to be able to send that information over to other chains. And also, I think it is here. I based this tutorial on another tutorial that is on Spark IBC's YouTube channel. What they did there was basically start from scratch, from 0 to hero, to create this polling app, but that was not IBC enabled. So what we're going to be focusing on today is just to make that IBC enabled. One more thing I want to kind of emphasize is that in this setup, I intentionally put a lot of different chains that you see, for example, Juno, Neutron, and the Cosmos ecosystem. ETH, obviously, because we're with IBC SDK, and Polymer, we're targeting Ethereum developers. But also, like, Mia, for example, I think they're here today. Eclipse is the team that we're working with, and, all, different kinds of rollups. And the idea here is that I think if we really want to see this cross-chain, multi-chain future deliver, that we can't just think that we have one chain that is CosmWasm and Cosmos, and then another chain that is also Cosmos. And so what I tried to do in this particular tutorial is to make sure that instead of just having a poll, we vote on it, and then we send over that data and then have an action. What we're actually going to do is not interchain accounts, right? Because if you think about it, we have to send it into another chain and then have an action on the remote chain based on some data that happened on the source chain. That might scream like interchain accounts. But what I tried to do is to make it more generalizable. So basically we have a voting app here that enables you to vote on any three options and then send it over to any chain, and that chain can choose what to do. So the logic in your contract on the other side is something that, for example, you could be doing in the hackathon. And so that's not just executing, for example, a staking transaction on the remote chain. All right, so maybe the first step when you want to create an IBC-enabled contract is, okay, where do I start? And that's a good question. And personally, I started from this tutorial. It's from the IBC Go wiki. So it's called CosmWasm and IBC. And there's some explanation as well, and some resources that you can follow. I think then all the way on the bottom, there's essentially the explanation to create an application that is very simple. from what it does, it basically enables you to send messages from one chain to another, and it counts how many messages it has received, and it stores the latest message. But even though this is pretty simple in terms of application logic, there's quite a bit of boilerplate code that is actually included in this, and so that's what we're going to go through now. But that's why I think it's useful to start from a repo, for example, the one in the wiki, or you could just clone, of course, the one here in the repo for the demo, and then you can take a look and just go through it and see what's being done, because I think that's also important, not to start from scratch, because IBC can appear complicated. It's good to have like this boilerplate example. For those purposes, I also linked to some documentation right here. And this is going to link to my personal repo, but this is the documentation pre-release for the IBC SDK. So if we go up one level, what we're going to try to achieve with the IBC SDK is to enable smart contract developers from different ecosystems to write IBC-enabled contracts. And so there's a couple of things that we need to do in terms of education. And for each ecosystem, here is the CosmWasm and EVM. We have a similar structure, and that's essentially first we have an introduction, so CosmWasm Developer Essentials. This is just like a brief introduction with also a list of other resources that you can use. That's one thing. And then the other two are the most important. So suppose that you're a CosmWasm developer. The first thing that you're gonna be looking at is, okay, how do I actually make my contracts IBC enabled, right? Let's see. So I'm not sure if everyone here is familiar with IBC. I'm going to assume at least some familiarity. So from the application developer point of view, what happens is that you first need to set up a channel. And so this is something that the IBC SDK does. You can create a channel when you deploy your smart contracts that will use the smart contract address in the support ID. Then we have the four-way handshake. And this is listed here as well. You see here. So in IBC we have open init, open try, open act, and open confirm. Those are the four handshake steps where we're essentially going to do some version negotiation. Something to look out for. If we look, for example, here in IBCRS, okay, this is good to mention. So usually in your CosmWasm smart contracts, you would have your message.rs, your state.rs, contract.rs, helpers error. But when you're working with IBC, you also have a smaller one, which just defines the ACK. And then the main one, which is IBCRS. And IBCRS is going to include exactly this, which is essentially the handshakes and the packet callbacks. So when we look through it, here we have IBC channel connect, and before it, IBC channel open. And now if you're familiar with IBC, you're probably thinking, okay, I can only see two. That's because in this particular CosmWasm implementation, the channel open, for example, is either the open init or the open try. So here you get these two, because depending on where you start the interaction, you're only ever going to have one of these two in each case on each chain, and that's why you can limit it to channel open and channel connect. So there's nothing really different going on here. You also have one for the closing of the channel, which is a bit less important. And then next to the channel handshakes, we also have the packet receive, the ACK we should also have. And if this sounds unfamiliar, you can both read it here. We can also go to the envisioned Developer Academy. And when you look here, Introduction to IBC, should be on the channels page. Application packet flow. Here, this is the one I mean. So this should be familiar to you. If it's not, please read it. This is a good overview of packet flow. So we have a user on the left who is triggering a send packet. Relay is going to query for that, or an event is going to trigger it. Then we have the receive packet on the destination chain, which is going to execute some logic and also write an acknowledgement. This acknowledgement is going to be submitted on the source chain, the original chain, by the relayer. And this is in the happy path, and in the other path we have a timeout instead of the app. Here we go. And so this is essentially what you will be coding also into CosmWasm. But like I said, if you start from this example, a lot of the boilerplate will already be included. All right, but maybe let's start first, just taking a look. So if we look at the states, we here have some channel states, which was from actually the original example. We have a admin address, so this is just for the instantiator of the contract. Then this is a struct related to our poll, so we have here our three options, the votes for each option. Then if it's active, we can only send an IBC packet when the poll has ended. And then the IBC success boolean. So basically, when we send a packet, it could be received on the other chain. That other chain is going to, if that's successful, going to send over an ACK, and upon the ACK, we're going to update this IBC success so that someone else doesn't try to send the packet again. All right, and then we take a look at the messages. So these messages, create poll, vote, and end poll, have nothing to do with IBC. They're just helping us to create the voting logic. The queries are not super important here. And then we have our main function, which is send poll result. And the input here is the channel. So we'll have to give the channel for IBC, and then two parameters, the poll ID and the voted option, which essentially give us the packet data. And this is something I skipped in the state, that we also define our packet data, basically having those two fields. Okay, so this is an execute message. If you remember, in CosmWasm, you have a number of entry points. You have instantiate, and you have the execute messages and the queries. And then, send poll result is how we're going to send our initial packet. And so we know if we define this message, we're probably also going to use it. Like I said, entry point instantiates. This is just on an instantiation of the contract. And then the most important ones are here in execute. And again, we're going to focus on this send poll result. Again, we have the input of the channel, poll ID and the voted option. And it's going to try and send this poll result. Do this. So here we're going to define our packet data. And as we do in IBC, we are going to send our packet with the data field, timeout field, and then also the channel ID. And something to note here, and this is related to the actor model in CosmWasm, is that the flow in CosmWasm is so-called fire and forget. So if we trigger this, send poll results path, it can't wait until the packet is sent and until the response is back. So what it does is just it prepares the packet, and then ultimately it adds to the response. It adds the message, which is a wrapper of send packet. And this is an important concept. And actually, when we go back, In this diagram, which kind of shows how CosmWasm works, it's important to realize that we have the CosmWasm virtual machine on our Cosmos SDK chain, right? And our Cosmos SDK chain has, the IBC module with, the core handler. And so when we go back to the code, when we try to send our IBC packet, we don't need a lot of extra code. We're just, calling into the native IBC's module send packet method. Should be on the connection here. Right, so this is an important pattern if you're using IBC. For CosmWasm, and also if you're not using IBC, in CosmWasm it's always firing forget, so you add messages for another actor to execute. Okay, so if we go back now, what we have implemented is the send packet, and then we need to go to receive packet. But actually, when we look at our setup, what's going to happen here is that we're only going to send our voting information to other chains, and so we do not expect another chain to send this to us. And so this is an asymmetric situation, and we're actually not expecting to receive any packets from the other side. And this is why I left here. Let's see where it is. We should go to IBCRS. So this is where we define our packet callbacks. When we look at the receive packet, here it is. We have do IBC packet receive. And so this is actually one that is remaining from the initial template. I left it in there because it might be good for you to see. But in this case, if we only wanted to send our voting packet logic, we could just leave this blank because we are not expecting packets to be received. And so in fact, the only thing that we would have to do is move to the packet ACK. And so, like I said, on ACK, what we're doing, we're reconstructing the packet data. We're loading our poll, and what we're going to be doing is we're just going to set the IBC success to true, which means that if the packet has been received on the remote chain, that means that we don't have to send another packet anymore. So going back to our diagram, now we have implemented the send packet, the ACK packet. We realized we didn't have to implement the receive packet. Now, obviously, if we wanted to be a developer in both the source chain and the destination chain, this is something where we still have to do. But for example, you could also do this on the Solidity or EVM side, right? Depending on what chain you're targeting. And actually, in our documentation, this is the other part. So one part is if we're on the CosmWasm side and we want to write IBC-enabled contracts. The other is if we want to write a contract that needs to interact with a CosmWasm contract. And this would just be generated by the schema. And so we have a JSON file that essentially contains all of the information that we need. If we are, for example, on the other side, that could be CosmWasm, could be EVM. This contains all of the information that we need to have a cross-chain call. And the documentation also includes that for EVM. So this would be using Polymer and the VIBC core smart contracts that we need to implement. And the reason why we need to do this is because on Ethereum, we don't have this native IBC module, our core IBC handler. And so what we achieve with the virtual IBC smart contracts, which Polymer would have deployed on Ethereum, for example, it just makes it an easy contract to call. We can do the send packet as we are used to. So as an application developer, we can just call into the send packet of the VIBC smart contract, and then a relayer, a special type of relayer, would pick this up, move this message onto Polymer, and Polymer would execute the core IBC logic as if it were actually on the same chain. So it basically separates the IBC logic across different blockchains, which is an idea of modular interoperability. I guess that concludes everything. You can probably take a look after if this is new to you, but yeah, just if you start from this template, I think just looking at the different examples, it should become clear what to do, and there's always, you know, the additional information on the IBC protocol and the documentation that I linked. When we look at it, it also has some extra information on Polymer if you're interested in that. Also, you know, look at the workshop I did in March. For example, it explains why we have, you know, difficulties when we have to extend IBC beyond Cosmos, is because we have a number of components that would have to be developed. If we're using Polymer, that's ultimately going to be easier with virtual IBC. So you can have a read about that. And then there's also there's also some general information about IBC, but some resources. And I guess the last thing that you can do is, you know, what are the next steps? So right now we have our voting contract on one chain that is IBC enabled, but then, you know, the question is, where do you want to send it to? And on the receiving chain, whatever it is, if it's CosmWasm chain, that would probably be, you know, the most relevant for this event, but it could also be Solidity. What can you do? Well, first simple thing to do is, you know, you can build tests for the contract. Another thing you could do is you could build a contract on the receiving chain that uses the full IBC packet data. So that is actually something I'm going to do myself for another conference that is coming up quickly. I'm going to do that in Solidity, but you could also do it on CosmWasm. You could do a similar thing for your own application. So like I said, you know, using this boilerplate, using this template, you could make your own version. And then right now, you could use already Starship to quickly spin up your dev environment and, you know, test out your packets. And then a little bit more advanced is maybe introducing interchain accounts somewhere in the application flow. And I linked to a repo of Serdar, who is a developer advocate for relations at the IBC Go team. And he has implemented a CosmWasm interchain accounts controller contract. Something else you could take a look at. Also, I linked to a blog post on ADR8. And what ADR8 enables you to do is when you have, say, for example, a transfer that you transfer from one chain to another, ADR8 allows you to have callbacks that call into the transfer. And so you could, for example, have, you know, transfer equals action in one flow, one related flow. But that's another thing you could check out. And of course, you know, like I said, very soon, this will actually be for next conference. We're going to open source IBC SDK. And so also, you know, in this repo, I'm going to build on this example. And like I said, I'm going to also have on the EVM side, an application that uses a lending borrowing contract. Then you could use, for example, your voting application on CosmWasm to vote on what asset to borrow. It's going to send over that packet, use the IBC SDK to let it go through Polymer, and then you know, receive the packet and then have the go back. And that's you know, other things that you can build on top, like I said, with interchain accounts, with ADR8, so the possibilities are open, and yeah, I guess that's it. I don't know if there's any questions from anyone.
Do you have any idea how close ADR8 is to being qualified?
The team is behind you, but I think it's ready. It's ready to be built.
That's amazing. Yeah. That was me answering the next question.
All right. Any other questions? If not, I would definitely say to look out for the open sourcing of IBC SDK. It's actually going to be under the OpenIBC GitHub repo. And yeah, I hope to see someone else either at the hackathon tomorrow or at Nebular in Paris. All right. Thank you, everyone.